Assalamualaikum warahmatullahi wabarakatuh and a very good day. So we are still in AC circuit analysis, but this is the continuation of the sinusoidal waveform. So actually the best method or the most powerful method to represent the sinusoidal is what we call phasor, okay? Phasor. So phasor is the most powerful method. So because what we know that before this we have already learned about the expression of the sinusoidal waveform, which is we can express as a Vm sine omega t plus any phase difference, okay, phase angle. So this is, I would like to remind again, this is actually radian, this is degree. Okay, so what is omega? Omega is actually angular velocity, which is the unit is radian second. So omega t is actually radian second multiplied with second, so you cancel out. So that's why omega t is actually okay, radian. So as you can see, the expression is quite long and maybe will be a troublesome for you to actually write down. So actually the best way is actually to rewrite this expression in what I call a phasor form. Okay, so before we proceed, what is phasor? So it's actually we need to understand the origin of this phasor form. So actually the origin of this phasor is actually come from the complex numbers. Okay, so what is complex numbers? So a complex numbers can be represented what we call in a rectangular form. I think this one has been already taught to you during your high school level. So this is your complex numbers, which is z is equal to the real number and the j, which is, and then jy. So this is what I call the real component, and this is actually imaginary component. Okay, and these complex numbers can be represented in a phasor form. So this is the phasor form. Okay, z, which is x plus jy. This is what we call rectangular, can be represented by a phasor, which is r, a magnitude with an angle of theta. Okay, so this is what we call phasor form. Okay, so these complex numbers actually can be represented in what we call in a diagram, which is this one. So this is the real part, and then this is imaginary, which is j. Okay, so for example, using rectangular form, z is equal to x plus jy. So x will be the the position at the real part. So for example, this is your x, and your y will be represented at the imaginary part, which is this is jy. Okay, the intersection between this position, okay, will give you the total value, which is this is r, and we have an angle which is theta. Okay, so that's why in rectangular, if you can, this can also be represented in terms of phasor, which has a value of r with an angle of theta. So based on Pythagoras representation, this r is actually can be calculated by using this formula, x squared plus y squared, y the angle theta can be represented as a inverse tangent of y over x. This has been shown in the slide here, as you can see here. Okay, so actually the value of this one is actually r. Okay, and this is your x, which is the real axis, real part, and this is your y. So the intersection between these two parts will give you the magnitude with a phasor. Okay, and this real number also can be represented in, so meaning that okay, it's actually, this is this value x, you can write down as a r cos theta, and this part is actually y, can also be written as a r sin theta. So meaning that z is actually, you can come, is x is actually r cos theta, and y is actually r sin theta. Okay, so as you can see this one. Okay. And this is the, I think this one has been already taught to you during your high school test, during your high school time. So this is the addition, subtraction, multiplication, division, reciprocal, square root, complex conjugate that involve all the mathematics, okay, in complex numbers. Okay, so this is the addition. As you can see, you cannot, you need to actually add the real part with the real part, the imaginary part with only the imaginary part only. The same thing goes to subtraction. So you can only, for example, z1 minus z2, you can only actually subtract the real part with the real part and the imaginary part with the imaginary part. And for the multiplication, for example, you have this is z1 in the Phasor diagram, in the Phasor form is theta 1, and z2 is r2 theta 2. So if you are required to multiply z2 multiply with z1 multiply with z2, so you will actually got the magnitude multiply with the magnitude, but the angle you need to actually add, okay, addition. So actually the angle will be the addition. While if you are required to divide z1 over z2 division, so meaning that you need to have this formula r1 over r2, but the angle must be subtraction, theta 1 minus theta 2. Okay. For the reciprocal, for example, you are required to have 1 over z1, so meaning that 1 over r theta 1. So the result of this is actually 1 over r, and the angle is negative theta 1. Okay, and for the square root, if you are required to actually square root z1, so what you need to do is actually you need to square root the magnitude, but the angle is must be divided by 2. Okay, so this is the basic mathematical operation for the complex numbers, and if you don't remember this, you need to refresh again, okay, because this will be used in our class. Okay. And next is we go for an exam exercise, very little exercise. So evaluate the following complex numbers. So we have two exercise, A and also B. Okay, for example, question A. Okay, so 5 plus J2 minus J plus J4 minus 5, 60 degrees. So if you have been given like this, so what you need to do is actually to actually solve the multiplication first. Okay, so the easiest way is actually by using calculator, of course. Okay, but for manual, for the learning purpose, what you need to do is actually to convert it into a Phasor diagram, a Phasor form first. Okay, so by using calculator, what you need to do is, for example, this one, 5 plus J2, what you need to do is actually to key in the number 5 plus 2i, okay? So what you need to do is 5 plus 2, and you need to actually press shift button and then I. So this will give you 5 plus 2i, okay? And then to convert into a Phasor form, so what you need to do is to press shift, okay? Shift and then press plus button. Okay, so you will have your value, which is 5.385 with an angle of 21.8 degrees. Okay, and for this one, -1 plus J4, you need to convert into a Phasor. So this one should be -1 plus 4i, and then you need to actually press shift plus. So you will have the magnitude is in the Phasor is actually 4.13, and the Phasor is actually you need to press shift equals button. Okay, angle. So to multiply this, okay, so the multiplication will result in 5.8, sorry. So what you need to do is actually to multiply these two numbers. So 5.385 multiply with 4.13, okay, and the angle should be in addition, 21.8 plus 104.1. So this should be 5.385 multiplied. So should be 22.2 angle. This one 21.8 plus 104.1. So this one should be angle 125.9. Okay, and then after you have obtained the result of this multiplication, so then you need to proceed with the next operation, which is the subtraction. So 22.2 angle 125.9 minus 5 angle 60 degrees. Okay. Okay, so this one can be simply solved by using calculator. So this one in a Phasor form, so we can actually key in the Phasor form inside your calculator, 22.2 And then to insert your face, the degree form is actually just press shift, and there are negative button there, press that. So, and then you need to key in your angle value 125.9. Okay, and then just then minus 5, and then to key in the angle is shift minus 60 degrees. Okay, so this will be okay, so this will give you the value in terms of rectangular form. So we'll have negative 15.5, and the imaginary value is J 13.65. Or you can actually convert it in Phasor directly from your calculator by pressing Shift plus. Okay, so your calculator will give you the value 20.6, and then the angle you need to press Shift equal. So this one will give you the answer of 138.65. So this is actually the answer, the final answer.